Okay, we're coming back. Here we are, Chapter 7, Day 1, Part 2. I don't even know if I said Part 1 and the other one. You know what? I don't really care. Okay, so here's this graph of salary versus wins, and here's my relationship. It's 0.49. So let's talk about R for a second here. Here I have an app, and there's a website that has this too, and I have no idea what that website is right now, and I'm not worried about it. Here it talks about the correlation coefficient. And what we're looking for is we're talking about the correlation coefficient being a value between -1 and +1. If you have a correlation coefficient of 0, what 0 means is that there is no linear relationship at all. There is nothing there that says that it's linear. And keep in mind that what this is an example of what a linear relationship would look like that has a correlation of 0. And basically it looks like, hey, you know what? Someone sneezed on the paper. There it is, achoo! There, we've got that nonlinear pattern at all. But that's not the only way that you could have nonlinear pattern. Because, for example, if I had, for example, a data set that did something like this, I would say, hey, look, here I have my data forms a parabola. There's certainly a relationship here, and it's probably one that I could explain with some form of function. So there is a relationship, there is an association. But if I were to look at the correlation coefficient for this, for a linear correlation, I would get that R is equal to 0. And why would I get a correlation coefficient of R is equal to 0? Because there is not a linear correlation. There's a parabolic correlation. And why is it 0? Well, you know, it's probably 0 because I've got a positive correlation here, I've got a negative correlation here, and it wouldn't be consistent at all. I've got a correlation coefficient of 0, no linear correlation. However, if I have a correlation of 1 means that I have a perfectly linear correlation. And I know exactly what's going to happen. If I plug x into my equation there, I know exactly what's going to happen. And if I have -1, it is also a perfect linear correlation. But if it's 0, I've got nothing. And then I have varying strengths from 0.1 to 0.2 to 0.3 to 0.4 to 0.5, which is about what we have for our baseball data set. And it continues getting stronger until we get all the way up until 1. Now we have to keep in mind that as we're talking about this, a correlation of -0.8 and a correlation of 0.8 have the exact same strength. Even though positive 0.8, as we think about it, is greater than -0.8 as we think about the actual values of the numbers. The negative sign does not talk about strength. The negative sign only talks about direction. So the sign in front, whether it's positive or negative, only talks about direction. The strength really is, we're talking about the value between 0 and 1. So there are all sorts of different values that you can have for this. And if you're in my class, you have gotten a handout from this. If you're not in my class, I don't have that on the wiki. Sorry, I created it once and I haven't created it again. And sometime in the future it will be on the wiki for Chapter 7. But we can see that it becomes more linear the stronger it becomes less linear the weaker it becomes. So let's go back and talk about this, okay? So here we are, as we talk about this, shape, it's linear. Direction, it's positive. As salary increases, wins increase, and strength, it's 0.49, and it's a positive 0.49. And be careful because, you know, trick questions could very easily be, oh, what happens if you get a correlation of 7? You can't. It's got to be that decimal between 0 and 1 as we think about it. Now, did you know that the Japanese absolutely love baseball? They do. Japanese love baseball. So much so, in fact, that an entire group of corporations from Japan have formed a conglomerational group, and they are buying Major League Baseball. And they're going to move every single team to Japan, which means all these players, their salaries are going to be paid in yen. Now, in 2007, when I made this, the conversion rate was something like 204 yen for every $1. And since the dollar has tanked since then, I think it's like 74 yen per dollar. But I'm going to go with the data that I have here, okay? So here's what's going to happen. I'm going to create a graph that is dollars versus, or sorry, salary. So no, it's not going to be that either. I'm going to use yen to predict the number of wins. So I'm going to drag yen down here because yen is my salary. It's my predictive value. I'm going to drop it down, wait for the sound effect, and boop! There it is. Hey, look! There's the Yankees. By the way, the Yankees were making like 565,006 yen that year. That's a big chunk of money. Okay, so as I bring the wins down here, what's this graph going to look like? What a great question. Pause it, think, make your estimation, okay? And here we go. Bring the wins down here and shabam, there it is. It's the same graph. Now it could be distorted a little bit just because of scale, but it should be relatively the same. So then the question becomes, what's the correlation coefficient going to be between yen and wins? Here it was 0.49. But we took all of those values and multiplied it by 204. Am I going to take that correlation coefficient and multiply it by 204? Well, that's not a great question because it can't be greater than 1. So no, I'm not. What's the correlation coefficient going to be? Well, let's find out. But I bet you have an idea. Let's drag this down here. There's our summary statistics, and we'll have yen versus wins, and it is 0.49. It is the exact same value. And think about why this makes perfect sense. Because what I've done is I've changed salary to yen. I've changed the scale. That's it. I've changed the scale. I have not changed the actual relationship between the data. Now think about this in another perspective and see why this makes perfect sense. That the correlation coefficient is not going to change. Say for example that we take the temperature today and it happens to be really, really warm, and let's say that, no, you know what, let's talk about temperature and altitude, okay? We'll use altitude to predict temperature, but we're going to do temperature in Fahrenheit. So we're going to say that if I'm at, say, 3,000 feet, I'm going to predict the temperature in Fahrenheit, okay? But what I'm going to do is I've got altitude here, and I've got temperature here, and I get a value right there. Then I'm going to change it from Fahrenheit to Celsius, and I'm going to change the scale to Celsius. What's going to happen to the relationship between the altitude and the temperature? Nothing. Nothing, because I haven't changed the temperature, I've changed the way that it's measured, okay? And what we're talking about here is this. I'm talking about the relationship between the amount of money and the number of wins, and the amount of money and the number of wins. Are these payers actually getting paid more money? The answer is no. They're getting paid in a different brand of money. If this was altitude versus temperature, I'd say, did the temperature change? And the answer is no. The temperature didn't change. The way I measured it changed. So therefore, since the way I measured it changed, the correlation coefficient is not going to change. So, important. When you change the scale, correlation coefficient is not going to change. All right, coming back after the break.